Welcome to the IaC Cost Tracker by Binadox, your solution for managing infrastructure as code expenses. If you're using cloud infrastructure, you're likely using Terraform to define your infrastructure as code. This approach offers tremendous convenience. Your entire infrastructure is visible at a glance. You can implement version control and deploy everything from the command line with just a few keystrokes. But do you truly know how much it will cost to deploy your infrastructure? When examining your code, can you easily identify which variables impact specific resources? What if your code inadvertently creates security vulnerabilities, such as a database exposed to the entire internet? In this video, we'll demonstrate how Binadox solves these critical challenges. Everything begins with your infrastructure code, which typically resides in a corporate repository. While Terraform helps you define your infrastructure, the Binadox IaC Cost Tracker lets you track and manage infrastructure as code expenses. To start using IaC Cost Tracker, first add your repository with Terraform files by connecting it through SSH or HTTPS, or integrate directly with one of the supported services like Azure, Bitbucket, GitHub, and GitLab. Now, let's look at an example. We'll use a Terraform repository for setting up AWS infrastructure. In this video, we demonstrate common challenges users may encounter when setting up infrastructure as code and how Binadox helps solve them. Firstly, users lack real-time visibility into infrastructure costs, leading to unexpected budget overruns. To solve this problem, Binadox offers a dashboard that provides a quick overview of your infrastructure as code. At the top, you'll find 6 key indicators of your cloud infrastructure: cost savings, security, performance, reliability, best practices, and compliance, each showing a numerical score to help you gauge your infrastructure's status at a glance. This comprehensive monitoring helps prevent unexpected budget overruns and ensures infrastructure optimization across multiple dimensions. To address the challenge of tracking infrastructure spending patterns, the central feature of your dashboard is the dynamic price monitoring graph, which provides a visual representation of your infrastructure costs over changes. This tool helps you identify trends and catch any unusual spending patterns early, preventing costly surprises and enabling proactive cost management. At the bottom, you'll find the next section with 2 tabs: Issues and Commits. To improve your infrastructure's security posture and adherence to best practices, the Issues view lets you track and manage various infrastructure concerns through a searchable table interface. You can filter issues by name, severity, and risk level using the provided filters. The table displays each issue's ID, category, and risk level, helping you prioritize what needs attention first. This automation saves significant time and ensures no critical security vulnerabilities or best practice recommendations are missed. To address the challenge of understanding how code changes impact costs, the Commits view helps you track how code changes affect your spending. Each entry shows who made the change when it happened, includes a commit hash for reference, and displays the associated price impact. This transparency enables better team collaboration and ensures cost accountability across your organization. The Overview tab shows a detailed cost comparison across different commits of your project. This addresses the common challenge of understanding cost implications before deploying changes. On the right side, there's a commit selection panel where you can choose specific commits to compare, ordered by date, and showing the associated costs. Each commit also includes information about variable configurations that were changed. This feature enables teams to make data-driven decisions and optimize configurations before deployment, preventing unnecessary expenses. At the top, you can see commit hashes and total cost. Below them, there is a breakdown of costs. Infrastructure pricing consists of 2 components: deployment cost and usage cost. Deployment cost can be calculated with precision, while usage cost cannot be known with certainty, but we can estimate this price using the intensity of use. The Show Cost with Usage checkbox will show you an approximate cost estimate. Binadox helps you calculate these costs using different intensity levels. When you click on a price, a detailed panel opens on the right where you can see both the basic deployment price and the estimated usage price. To address the challenge of predicting future infrastructure costs, the Usage Settings button helps you estimate costs based on expected resource consumption. Pick from 3 simple options: low, medium, or large, for a quick estimate. This provides clients with a rough approximation that offers a general understanding of potential costs. This feature helps teams plan with confidence and make informed decisions, even though usage costs are inherently variable. A resource's price can display two key statuses, disabled and none. The disabled status helps identify resources that won't be created even though they're defined in your configuration. For example, if the EC2 instance count is mistakenly set to 0, the resource will show as disabled, helping you troubleshoot why no instances were created when you expected 5. By clicking on the disabled status indicator, you can view explanations about why the resource won't be deployed. The none status means the resource wasn't defined in the code at this particular commit point and was added later. Understanding these statuses helps you quickly identify configuration errors and track your resource utilization across different versions of your infrastructure code. To address the complexity of understanding variable dependencies in Terraform, the Variables tab allows you to recalculate the total cost of your infrastructure and understand which specific project resources are impacted by each variable change. Terraform's structure makes it difficult to understand variable dependencies. Binadox simplifies this by clearly showing the relationships between variables and their dependent resources, enabling better cost optimization decisions. Before accessing the Variables tab, you can select a commit from the Commit Selection panel on the right side, which shows the date, author, commit hash, and the associated infrastructure costs for each commit. You can filter by price and date of commit. To start, we should select Commit, in which we want to simulate different variable values. Once you've selected a commit, the Variables tab displays a breakdown of your cloud infrastructure resources and their costs on the left side, with the total cost at the top. On the right side is a list of all variables that affect your infrastructure resources and, consequently, the infrastructure price. You can search for specific variables using the search bar. For example, let's change the EC2 count, which currently has a value of 15. This represents the number of EC2 Splunk servers to be launched, as indicated by the helpful description below the field. You can modify this value to see how increasing or decreasing the number of instances affects your total infrastructure cost. After making changes, you can use the Recalculate button to update the cost estimates. By clicking the Show Only Affected Resources checkbox, you can filter to display only resources impacted by variable changes. As you can see, increasing the EC2 count has raised our total cost from $46,800 to $47,300, with the highlighted auto-scaling group cost doubling from $456 to $911. This instant visualization lets teams immediately understand the financial impact of their infrastructure changes. While understanding cost implications is crucial, maintaining the quality of your infrastructure code is equally important for long-term efficiency and stability. To address the challenge of maintaining infrastructure code quality, the Resource tab gives you direct access to your Terraform configuration files and their contents. It features two main areas: a file explorer on the left showing your project files and a code viewer on the right. You can toggle between two viewing options: Code View, which displays the raw content of your configuration files, and Blame View, which shows line-by-line commit history, including author information and timestamps for each change. These views enable you to not only inspect your infrastructure code but also track who modified specific sections and when those changes occurred. Building on this code visibility, to proactively prevent infrastructure issues, the Warnings tab helps you identify potential problems in your Terraform configuration files. On the left side, you'll see a list of your project files, and below that is a warning section that displays any detected issues. This automated monitoring ensures adherence to best practices and helps avoid configuration errors that could lead to unexpected costs. To improve team collaboration and cost transparency, the Commit Comparison tab lets you analyze changes between different versions of your Terraform configurations. The interface shows line-by-line differences in your configuration files, highlighting changes in variables, instance types, and other settings. This feature enables teams to track who made changes and when, ensuring better cost accountability across the organization. Building on this change visibility, Binadox enhances team communication with its integrated feedback system. The comments feature enables immediate cost impact tracking for each infrastructure change. This solves the challenge of maintaining clear communication about infrastructure costs across teams. Following every commit, team members can discuss and document financial implications in real time, with each comment showing author and timestamp information. To ensure comprehensive infrastructure quality, Binadox automatically detects and tracks 5 types of infrastructure issues: best practices, cost savings, reliability, security, and performance. This automated analysis helps teams maintain optimal infrastructure while reducing operational costs. The system quantifies these issues and tracks their resolution over time, generating analysis reports either immediately after each commit when integrated with your CI or C pipeline, or once per day if pipeline integration is not configured. Now you know how IaC Cost Tracker helps control your infrastructure spending through analysis and team collaboration. Start optimizing your costs today. Thanks for watching.